42 on 510, 42. dy over dx equals 7 over y squared. Yes, I highly recommend cross multiply first. So y squared dy equals 7 dx. They are already separated. Y is alone on one side, x is alone on the other. There is no combo of x and y. And that's what I wanted. Next step, you already told me I have to integrate. There is no need to put c on both sides. On one side is good enough. This is y to the third over 3. I should write plus c. Instead, I only put 1. And this is 7x plus c. Multiply both sides by 3. Y to the third equals 21x. I should write 3c. Instead, I write plus c because 3c is a constant. If you'd like to write c1, c1 will be 3 times c. How do I solve this equation for y? What do I need to do to both sides to solve for y? What operation we apply to both sides? Excellent, thank you. That's it. C or C1, it doesn't matter. Constant. It can be anything. Let's also look at something maybe somewhat easier, like 24. And then I'll let you choose again. Y prime equals 3x squared minus x plus 5. And we are told on the side that this is the initial condition, y equals 6 when x is 0. This is not the notation we need for differential equations. What should I replace that? They are trying to confuse us. Yes, dy by dx. And multiply both sides by dx. All done. There is nothing to it. This is just y. This is 3x cubed over 3 minus x squared over 2 plus 5 plus a constant c. Couldn't be easier. When x is 0, sorry. Please put the x. When x is 0, 0, 0, 0, then how much is c? Very good. Awesome. Indeed, c is 6. And that's it. So some of them are very straightforward. Some of them are more difficult. So y is x cubed minus x squared over 2 plus 5x plus 6 is the unique function that verifies the given condition. Okay, let's also look at 30. Please feel free to choose the next one. I'll be waiting for you to choose. So 30 dl over dt equals 0.68 L. We are told L is 1200 when t is 0. First, we'll cross multiply. dl equals 0.68 L dt. This number is fine, dt is fine, but this has no place here because dl is on this side. So I have to divide both sides by L. So dl over L equals 0.68 dt. Now they are separated. L is alone on one side with its dl. T is alone, there is no t, but dt is there. Now we integrate. And we get the natural log of the absolute value of L, which is 0.68 t. There is only need for one c, not on both sides. Okay, these are never really very friendly. So e raised to this, the absolute value of L, equals e raised to all this, 0.68 t, and I'm going to write times e to c, using that property that we used before. what property? One more time. A to m plus n equals a to m times a to n. Now I have to use the initial condition. So when t is 0, L is 1200. So when this is 0, all this is 1. So e to c equals 1200. So from here I know that e to c equals 1200. Similar to what we had before. So then the absolute value of L equals 1200, because this is 1200, times e to 0.68 t. Or just L, because the plus or minus can be included. 1200 e to 0.68 t. I'd like to look at a word problem unless you want to practice more.
Can we do more? Can we do,
Yes?
we do 38.
Very good. Awesome. I'm on 6. 38. 3y. Okay, 38. 3y squared dy over dx equals 5x. Perfect. Good. So first we'll cross multiply. So we have 3y squared dy equals 5x dx. Already separated. Now you can say I want to divide this and have here 5/3 and have all the constants on one side. That's fine too. It doesn't matter. It's simplified better. And what do I need to do next?
Integrate?
Yes. Very good. So we're integrating. The left-hand side, y cubed over 3. There is no need for c. 5/3 x squared over 2 plus the constant c. I have to get rid of this. So then y cubed equals 5/2 x squared plus, I should write 3c. I'm going to include it and say it's a new constant c1. And now I take the cube root. We're not given a condition. This problem does not give an initial condition, so we're asked to determine the general solution. So then y will be the cube root of 5/2 x squared plus c or c1, it doesn't matter how you want to call it. Very good pick. Okay, let's look at something like total profit. We can come back to more differential equations if you'd like, but I'd like to look at a word problem 56 from 511. Any questions for me, please? Let's stop for a moment. Any questions? Anything you'd like to ask?
It's just a small one, but the C1, you keep writing C1, but then you say the 1's not there. Is that just the same as the plus C that we've been writing the whole time? Or
Yes.
Okay.
Yes. So when I multiply here by 3, I should write that C1 equals 3C. But it doesn't matter. It's a general condition, general function, general antiderivative if you want. So it doesn't matter what C is. It will always go away if you want to go back and check. No matter what this is. If I write it as 3C or if I write it as 100C, it will still go away when we check the solution. So it can be anything. Yes, it's that C from the when we determined in chapter 4 when we looked at indefinite integrals. Yes, that's C.
Okay, got it.
Yes, because that's what we are doing. We're integrating. I want to erase these so I don't, if you look back, so you're not confused. Okay, so total profit from marginal profit. Hannah's head company's marginal profit P as a function of its total cost is given by dP over dC, and they say this is negative 200 divided by C plus 3 raised to 3/2. Okay, this is a differential equation. What do I need to do first? Well,
cross multiply DC.
yes, exactly. That's what all I need. I'm not going to move the constant here. So indeed, so negative 200. I will also write it as negative 200 times C plus 3 to negative 3/2 times DC. I'm getting it ready for integration. So I changed 1 over C plus 3 to 3/2 into C plus 3 to negative 3/2. And now we integrate. dP is P. P prime is 1. So that equals negative 200. And what do we do with this? Remember, it's C plus 3 to negative 3/2 plus 1 over negative 3/2 plus 1, of course, plus a constant C. Now, this is confusing. I'm going to use a D, constant D, because I don't want you to think that it's cost. Okay? So since we have C in the problem, I'm going to use D as a constant. Okay. Moving on. Good. So then P equals negative 3/2 minus 1 is negative 1/2, but I have to flip it. And it will multiply, so it's negative 2 times 200, so this is positive 400. Well, this is not good. So positive 400, and C plus 3 raised to negative 1/2, plus a constant C. So this is the profit function, or P of the cost is, because I don't want this to be confused with this, right? So 400 divided by the square root of C plus 3 plus a constant D. Use the profit function, find the profit function, sorry, and then if P equals 10 when C equals 61. So C equals $61 when P equals $10. Why is this information given to us? So this was part A, and now we want part B. Why is this information given to us?
Solve for D.
Excellent, thank you. So we're going to plug it in. So when C is 61, P is 10. So 10 equals 400 divided by 61 plus 3 is 64. The square root of 64 is 8 plus D. 40 divided by 8 is 50. 10 minus 50 is negative 40. So D equals negative 40. So then P of C is 400 over the square root of C plus 3 minus 40. At what cost will the firm break even? Oh, I'm sorry, this was not B, this is B. Break even means, anyone? When the profit equals
0.
Excellent. The profit equals 0, it means we break even. We're not making money, but it's still good. We're not losing money. The cost equals the revenue. Okay, so we set it equal to 0. So I have 400. This is no longer calculus. I have to set that equal to 40. Cross multiply. 400 equals 40, the square root of c plus 3. I divide by 40. 10 equals the square root of c plus 3. And what operation we apply now to both sides so we can solve. Square, because we want to eliminate the square root. So 100 equals c plus 3, or c equals 97. That's where the break-even